And hello, welcome to Math with Doug, Supercharged Math. I am Doug, this is Mocha. I think that the students mostly have encountered her before. I'm not starting with the math right away. As usual, I want the students to have time to come into the room, so I start yakking about some other things, like the weather, but the weather has been so uninteresting to talk about for months. I think it gets interesting when I have snowstorms and there are snow plows going by and giant snowbanks and things like that. But we'll have to wait, I hope, a few more weeks before we have that. Okay, I am wearing the Highlanders. That is a rugby team from New Zealand. And I'm not going to talk much about the shirt other than that. And I have this dog in my arms because I'm going to get Mocha involved in the lesson at least a little bit. I think the students like it when the beautiful assistant is involved in the math. It's just that sometimes it's hard to figure out what types of math she's able to help with. But I came up with an idea for this week. We are going to be talking quite a lot about improper fractions and mixed numbers. And to start with, I'm going to just put up an example of each, but I'm going to let Mocha choose which numbers I put in and around these fraction bars so that she's involved in the lesson. And as soon as I've done that, I'm going to release her upstairs. So I will walk off camera for a few seconds just so that I can release her upstairs because her supper is waiting for her up there. But what I have right here are a bunch of little dog treats. And that's why she is so intent that she won't even look anywhere near the camera. Maybe if I put the dog treats up where the camera is. There, see? Now she notices the student. She's looking right at you. That's the way dogs are. Okay, so what I'm going to do, I'm going to put her down. And she's going to be off camera while she's actually doing her job. Because, no. Okay. Oh, up here, Mocha, up there. Stay. She got too excited. She started leaping around looking for where the dog treats were. Okay, so what I'm going to do is I have the numbers from 1 to 9 on this piece of paper on my clipboard. And I'm going to put a dog treat on each number. Now, they're very small pieces of dog treat. So I'm doing that now. And the first 5 numbers that Mocha chooses when she goes at these treats are going to be the 5 numbers that I will put into those fractions. So that's how she's going to be involved. So I don't know if the camera sees this very well. Sometimes yes, sometimes no. It seems to have a bit of glare from the light above. I'm putting this on the floor, and then I'm going to let her go at it, and it's going to happen fast. Believe me, it's going to happen fast. Stay. Okay, go. So she took the 2, the 6, the 1, the 5, and the 8. Those were the first ones. 2, 6, 1, 5, 8. I have to write it down. And try not to step on a dog while I do it. 2, 6, 1, 5, and 8. I will arrange these into these fractions, but first I'm going to release the dog because she's finished all of those treats. They are gone. Believe me, they are gone. Okay, come here. Your supper's upstairs. Let's let you go. Come on, off you go. Okay, have fun. Please do the vacuuming while you're up there. It would be nice if she would help with the vacuuming, but as you know, dogs are afraid of vacuum cleaners. Now, 2, 6, 1, 5, 8. I want to arrange these in a way that's useful for an improper fraction. An improper fraction is one where the numerator is larger than the denominator, so I can't just randomly put them in. That's why I didn't let Mocha actually do it. I just let her choose the numbers. So I'm going to put, let's see. I'm going to put the 5 on the top and the 2 on the bottom. They're used. And then how about if we have 8 and 1/6 as our next number? Now, I will use these later, but I'm not really ready to use them yet. I need to get into my examples, and I always like to start with some simple examples. 5/2, that's pretty good. I'm going to put 8 and a 6 over on this side where we can see it. And that's Mocha's fraction that we'll use later. And I'm going to erase it from here. I'll erase these as well. Now, 5/2 is actually a pretty good one to start with. Yeah, but I'm not going to start with it. I'm going to put it over here, and we'll use it later. I have a strategy now for how I want to do this. So today's class, we're going to spend a lot of time practicing converting between improper fractions and mixed numbers. I'll erase this one. But I'll leave these terms, improper fraction and mixed number, up there for now because the exercises I'm doing don't require that much space anyway. So I'll start off just using the center and then I'll erase them after a while. Okay, when we convert an improper fraction to a mixed number, we need to take, I want to use as an example, how about 15 over 4. That's going to be our first example. And I have a little trick that I like to use when I first teach students about how to do this. There are all sorts of shortcuts, and a lot of students are very good at this. I'm sure that some of the supercharged students have already converted this into a mixed number. And if you do that, you're welcome to type it into the chat. It's fine when students type in answers into the chat. And of course, you can also type in suggestions for fractions that I could use. And sometimes I'll try to use those. I look at the chat and I see what's going on. I'm also going to look at something else because there is something I wanted to mention. Where is it? I have to find it. Yes, I wanted to remind the students about something that's important for this week, that Leah's study hall is going to be 1 hour earlier than usual. Just this one time, this Friday. So I want you to know that. I wanted to make sure that I didn't forget to say that. Okay, that's it for that announcement. Now, my trick for converting an improper fraction to a mixed number, which works really well for beginners, so the students who are really strong in advance have to, be patient with me while I do this, is we imagine that the 15 is the number of students who are in a gymnasium for a physical education class, or maybe it's a number of students who are in a dance club or something who are in the gymnasium. So I like to draw them, but of course drawing them can take a while, drawing 15 students. So I put simple drawings like just putting circles for the students. So here's 4 students. I'm not finished. I need 15 of them. 10, 11, 12, 13, 14, 15. And of course, the way the students are arranged inside this gymnasium is sort of random. You never know where the people are going to be because the phys ed class or the dance class hasn't started yet. But then the instructor walks in and says, okay, I need you to be in teams of 4. Well, the denominator is telling us that the size of the team. So what happens? The students will form groups with their friends, or they will form groups with whoever happens to be standing near them when they find out that they need groups of 4. And eventually you have all of the possible groups of 4 have been made, and we can see that 3 groups of 4 have been made, but then there's some students left over. And what are they? What those students are is the remainder. Now, remainder is a word in math. I'm writing it quite crooked, I realize that. But a remainder is a word in math that a lot of students have trouble remembering what it is. But to me, students who understand the phys ed way of converting an improper fraction to a mixed number are always able to remember what the remainder is. There are some people left over who they're not enough to form one of the groups of the size that we need, but they're still there. They're the remainder. So how do we convert the improper fraction into a mixed number? The big number that we have as part of the mixed number is going to be the number of groups that we made. So that's 3. And then we have the fraction bar. The remainder goes into the numerator. The remainder is the numerator in the mixed number. And then the denominator is the same denominator that we already had. So this works, and it's kind of fun, and it's something where you can actually draw it out if you're not sure so that you can see what you're doing. Students get very good at doing this, and they don't necessarily need to use so much time to draw it out. But if you need to draw it out, you do. So 3 3/4 is actually the same number as 15/4. It's just this is in the improper fraction form, and this is in the mixed number form. And we can see how to do this with the phys ed class. So let's practice this a few more times. And we'll start right away with a very, very small phys ed class, which is going to be Mocha's improper fraction. We'll use that right away. Same process. I look at the numerator to see how many people are in the class. And this time there are 5 people in the class. I don't have to draw little circles to draw the people. I can even draw little stick figures if I want. And since there's only 5, this time I'll do it. But usually I just like to use an X or a triangle or a circle or something like that. And we are told we need groups of 2. That's the denominator. So the people in the room form groups of 2. There's 1 left over. That's the remainder. 5 halves, therefore, is equal to big number is how many groups? 2. And then the numerator is going to be the remainder. There's just 1 in the remainder. And then the denominator stays the same. And we can see that 2.5 is equal to 5 halves. And a lot of us probably already knew that because this is a fairly small, simple number. So we can do this, and we can do it quite quickly in our head if we get used to the tricks that are involved. But when the number is small, it's a little bit faster and easier to do, and it's easier to see that the 2 numbers are actually equivalent. But we don't always have a phys ed class with only 5 students in it. What happens if there are more? So let's do another example. And I can erase Mocha's example now. Okay, how about 22 thirds? I'm going to write my mixed number over here. 22, okay, now I have to draw 22 students. I'm not drawing 22 stick figures. I'll draw 22 X's this time. That's 12. Okay, this can take a while sometimes. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 17. Yes, I have 22. And I need groups of 3. Now, we don't have to really be pretending that who's friends with who. That just slows us down. So basically, let's just form groups of 3 by putting together any 3 that are close enough that they can be grouped easily. And we keep on doing this and making groups of 3. Oh, that one's got a little bit crooked, but it doesn't matter. We can still see what we're doing. How many groups of 3 do we have? 1, 2, 3, 4, 5, 6, 7. That's my big number. What's the remainder? Just this one single solitary X is the remainder. And what is the denominator? It's always the same. So 7 1/3 is equal to 22 thirds. It still works, but as you can see, once you get to larger and larger phys ed classes, it takes longer and longer to draw these. So you want to have tricks to do this where you don't always have to draw a phys ed class. This is a good beginner thing to do. But when you have very large numerators, it becomes more and more inconvenient to do it. I will do one more, though. I've used that one. I've used that one. I'm going to do 13 halves. 13 halves. And I realize that Supercharged students have probably already converted 13 halves into a mixed number and correctly typing it in. So I take a look at the chat every now and then to see those correct answers whizzing by, although the chat can go by too fast for me to read it at times. How about 13 halves? There's my fraction bar ready for my next number. 13 is not so inconvenient amount. I'll do triangles, little messy triangles. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Halves, 2 is the denominator. That's the size of the groups we need. Very common size of groups needed for all sorts of dances and other activities. We draw all the groups we can find, then we count them. 1, 2, 3, 4, 5, 6. 6 is my big number. I need more chalk. The remainder is 1 again, and the denominator is the same. 6 1/2 equals 13 halves. It makes sense. It works. So anytime you're not sure, if you have to, you can draw the phys ed class. But if you can think of other ways of doing this, and I can, well, then we can do this faster if we wish. So I will make one that's too big to want to draw all the students in the phys ed class, and we will try it. And that example is 41 eighths. Let's see how large I'm writing. Try and draw things on the chalkboard a little bit bigger, make sure the student can see them. But it looks pretty good when I look at the video myself. Okay, 41 eighths. I do not want to draw 41 little X's. It takes too long. So what am I doing here? How many groups of 8 can you make if there are 41 of you? It's really the same thing. I'm just going up without drawing. How many times does 8 fit into 41? That's what we're doing. 8 goes into 41 5 times. How do I know that? Because I can count up by 8s if I need to. 8, 16, 24, 32, 40. And then if I went up one more 8, it would go up to 48, which would be too big. So 40, 8 times 5 is 40. My big number is 5. That's the thinking I'm doing. I'm just slowing it down and saying it out loud. If we do 8 times 5 equals 40, what's our remainder? We have to do 41 minus 40. So the remainder is 1. It's not always 1. It's 1 in quite a few of the examples, but it's not always going to be 1. The remainder is 1. The denominator is the same. That's the easiest part, is putting in the denominator because it's always the same. So 5 and 1/8 is equal to 41/8. We have a trick that works and we don't have to draw a phys ed class to do it. Okay. But then we think about this thing we were doing with the 8. We're counting up by 8s. What does that remind me of? 8, 16, 24, 32, 40. It reminds me of something very, very much, which is the multiplication tables. If you have that 12 by 12 multiplication table and you find the 8 on one side, there's a row that counts up by 8s. 8, 16, 24, 32, 40, 48, 56. If you know your multiplication tables, you know those numbers. And you are able to fill in the multiplication tables if you wish by counting up by 8s on that line where the 8 is. And then there's also an 8 at the top of the table or sometimes at the bottom. And you have the up and down row, 8, 16, 24. We're familiar with this. We've seen this a lot. So it's not really that difficult to slow down and remember, hey, I can count up by 8s to figure this out. And that is a way of doing it that doesn't involve all sorts of drawing and can be a little bit faster and more efficient. Did I do all of these original examples? No, I have one more that I haven't done yet. So I'm going to do it. I'm going to do quite a few more of these, actually, and I'm gradually going to try to make them a little bit more challenging. I'm also going to remember every now and then that the students need to occasionally stretch, and I like to stretch my shoulders because they become really tight when I do this type of activity with the chalkboard wall for some reason. And remember to take your sip of water if you need it. I have my fizzy water. It is pink grapefruit. Oh, and I'm remembering something that I forgot to do. And I'm not surprised. It's the sort of thing that I forget to do. I forgot to put my microphone on. The microphone is working. It's just it wasn't on my shirt. So I'm going to put that on now. Might not be working very well right now because it's inside my hand. Okay, that's on. And I'll clip this and hopefully the sound will be a little better because I'll be closer to the microphone. That should be good. It's flipped over a little bit. Let me fix it. Doug does his housework. I really hope Mocha is vacuuming up there, but I don't hear the vacuum cleaner. Okay, that was refreshing. My next fraction is 23/5. Make room, make my fraction bar for my mixed number, leave room for that big number. I'm going to need it. How many times does 5 fit into 23? 5 times 4 is 20. That's a bit of an easy one in the multiplication tables. 5 times 5 is 25. That would be too big. So the biggest number of 5s you can fit into 23 is 4. That's my big number. 23 minus 20 gives me my remainder, which is 3. Denominator is the same. 4 and 3/5 is equal to 23/5. They are the same number, really. This is an improper fraction. Don't forget the terminology. This is a mixed number, mixed because we have the whole number and we have the little fraction numerator denominator numbers. That's, I guess, why we call it a mixed number. Both numbers are useful. This can be considered a bit more simplified. It's a little bit easier to picture what you have when you have it in mixed number form. This version of the number, in my opinion, can be a little bit more useful when you're halfway through a problem. If you're about to multiply the fraction, then once you create it, you don't necessarily always want it to be in a mixed number form. I find improper fractions are more convenient to do stuff with. But for final answers, I love mixed numbers because it's a little bit easier to see what you have. If someone said, I have 23/5 pizza, it's hard to visualize what that means. If they say I have 4 and 3/5 pizza, oh, they have 4 full pizzas and they have another pizza that there's 3/5 of it left. There are 3 slices, then there were originally 5. You can see what you have with the mixed number. Okay, I'm going to do a bunch of practice and I'm going to make the numbers a little bit bigger and a little more challenging. And I'm also going to erase this phrase improper fraction to give me more room. And I'm going to erase mixed number as well, but I'm going to leave Mocha's mixed number in place so that we can use it later when we get to the other direction of doing this. We are learning how to convert improper fractions to mixed numbers, but we also need to be able to convert mixed numbers into improper fractions. It's very useful to be able to go back and forth with these. How about 32 ninths? And I can move over here a little bit more and write larger. 32 ninths. Make my equal sign a little bit less messy. Okay, how many times does 9 fit into 32? Counting up by nines. 9, 18, 27, getting close. Then 36, went too far. Just counting up by nines like I do in the 9 row of the multiplication table, I realize that 9 times 3 equals 27 is what I need right now. So my big number is that 3. 3 nines fit into 32 because 3 nines gives us 27. But it doesn't fit even perfectly into 32. 27 is less than 32. We have to do a subtraction. 32 minus the 27 equals 5. Our remainder is 5. See, the remainder is not always 1. Denominator is the same. 3 and 5 ninths is equal to 32 ninths. It works. It's fun. Okay, let's do a bunch more. I'll do some quite quickly. I'm going to take a look at the chat. Make sure that I scroll down to the bottom of the chat because sometimes I scroll up and then it stays up there and I can't see the new messages coming in. I did 32 ninths. How about 25 twelfths? How many times does 12 fit into 25? We're getting to the bigger numbers in the multiplication table with this 12, but it's still in there. If you're talking about the 12 times 12 multiplication table, 12 fits into 25 twice. That's still there. Okay. 12 fits neatly into 25 twice because 12 times 2 is 24. So that means I can fit 2 groups of 12 into this 25. The remainder is going to be 1 because 25 minus that 24 is equal to 1. That's my numerator. The denominator is the same. 2 and 1/12 is my answer. I'll do another one right below without erasing right away. How about, oh, I'm using 25 again, but 25 ninths. How many times does 9 fit into 25? 9, 18, 27, too big, so it's 2. 2 full 9s fit into 25. That gives me 18. 2 times 9 is 18. 25 minus 18 is 7. That's my remainder, my numerator. And the denominator stays the same. 2 and 7 ninths is equal to 25 ninths. It works. It always works. It is fun. We don't have to draw a phys ed class to do it. But if we feel like drawing the phys ed class, we can. Okay, those numbers weren't so big. How about 53 sevenths? Okay, 7 is not a crazy number, but 53 is getting a bit larger. But if we know the 7s in our multiplication table, 7 times 1, 7 times 2, 7 times 3, or counting up by 7s, which is the same thing. 7 times 5 is 35, not big enough. 7 times 6 is 42. I think I can fit another one. 7 times 7 is 49. That fits into 53. But 7 times 8 is 56, which would be too big. So 7 times 7 is what I needed. I multiply my 7 by a 7. My big number is a 7. 7 times 7 is 49. I have to remember that number. 53 minus 49. The remainder is 4. The denominator is the same. Wow, 747. That's a cool number. 7 and 4/7. Let's do another one. 34 15ths. Okay, now 15 is bigger than the numbers you have in the 12 times 12 table. You don't have a 15 in that times table, but of course you could. You could do a times table, a multiplication table that goes up to 15 times 15, or even 20 times 20 or anything you want. The multiplication table really goes on and gets bigger and bigger forever. And the more we do math, the more familiar we become with answers to all sorts of multiplications. And we start remembering some surprisingly large multiplications. How many times does 15 fit into 34, though? That's not such a bad question, not such a difficult question. 15 fits into 34 twice, because 15 times 2 is 30. So I have a big number of 2 again. Okay, But 15 times 2 is 30. I have to subtract. 34 minus that 30 is 4. My numerator, my remainder, is 4. And the denominator is the same. 2 and 4/15 is equal to 34/15. Not such a crazy big one. Let's see what else I have here. And also keep an eye on the time. I'm doing really well for time. Oh, I have quite a few more examples, though. I think I gave myself 20 examples of improper fraction to mixed number and 20 in the other direction. And we will be able to handle all of those. I think we'll fit all 40 of those into this lesson. But we also have an extra 2 that Mocha made up. So we did Mocha's, and we've done 5. We've done at least 12. So we're doing okay. And time-wise, that makes sense. It's proportional time-wise. How about the improper fraction 33 tenths? Bit of a fun one because it involves 10. And people are good at tens really early on before they even start doing their multiplication tables. The students get good at working with tens. How many times does 10 fit into 33? Yes, 3 times. 10 times 3 is 30. So my big number is 3. 10 times 3 equals 30. 33 minus 30 is equal to 3. So there is my numerator. My remainder is my numerator, and the denominator is the same. 3 and 3/10. We have our answer. How about 44/5? Okay. Kind of a cool one because 44 is a double number. Well, so is 33. And then we have 5. 10 is a round number. 5 is considered a round number. How many times does 5 fit into 44? 5 times 8 equals 40. 5 times 9 is 45, which would be too big. So my big number is an 8. 5 times 8 equals 40. I can write that. 5 times 8 equals 40. That's something that happened in my head. And then 44 minus 40 equals 4. This is how I'm getting the remainder. And I'm usually doing that in my head. So my remainder, my numerator of my mixed number is 4. And the denominator is the same. 8 and 4/5 is equal to 44/5. So this is really what we're doing. I think I'm going to show this again next time. I'll erase. And I'll put another fraction up there. And this one, 83/12. They're getting bigger. But if they get really big, does it mean that we can't do it anymore? No. Because the tricks we're learning with the simpler fractions will still work when we get to the more complicated looking fractions. How many times does 12 fit into 83? Well, there's more than one way of doing this. I'm going to do it another way. Even though I know that the tricks we've learned before will work. If we figure out how many times 12 fits into 83 using the multiplication tables, we will get the right answer. If we draw 83 students in a phys ed class, well, that will take a while, but we will get the right answer. But what about actually dividing? Let's remember that the divided by symbol looks like a fraction for a reason, because the division symbol is a fraction, or if you wish, the fraction is a division. We can do 83 divided by 12, and we know how to do this. So we can write an 83, we can show a 12, we can divide the way that we can, pencil and paper, and this is a useful skill to remember and to practice because we will need it again. When we move on to other topics, we'll be doing this again. But we're doing a fairly simple one here, where we're not going to try to get really far into the answer, really detailed into the answer. We are just going to use it to figure out how many times 12 fits into 83. So we can convert this into our improper fraction, which I'll put over here. Okay. 12 does not fit into 8. So I'm not going to be writing any answer up here because 12 is too big to fit into 8. So I have to use 83, not just the 8. How many times does 12 fit into 83? We're doing the same thing. We're just showing it differently. 7 times 12 is 84. We know that if we know our multiplication tables, but 84 is too big. So that means we have to use 6. What is 6? 6 times 12 is 72. And then we subtract. 83 minus 72 is 11. We can't fit 12 into 11. So we have to stop because guess what? 11 is our remainder. So the big number is the 6. The remainder 11 goes here, and the denominator remains the same. 6 and 11 twelfths is the same number as 83 twelfths. It works. If we want to show the division, that's another way to figure this out. All of these techniques are good. It's up to the student to decide which technique is working for them. Don't try to do the more challenging things too soon. Do the simpler approaches until you feel you don't need them anymore. And get lots of practice. Always with all math, get lots of practice. So 83 twelfths, that was an interesting one. And that puts me in a position to move on to my next page. Oh yeah, I have a few more with the larger numbers, with these sort of challenging looking ones. And we're just going to keep on doing it because we still have time. We have time to do a few more examples. We actually are doing really well with the time. Let me take a little sip of my fizzy water. It's amazing how much that helps when we're learning. Get a little bit of a refreshment every now and then. 80 ninths. How many times does 9 fit into 80? 9 times 9 in the multiplication tables is 81, but that's too big. 9 times 8 is 72. I think I like the 9 times 8 thing. That's going to be my answer, but I can count up by 9s. 9, 18, 27, 36, 45, 54, 63, not big enough, 72. I'm getting to the same answer. So when I'm counting up by 9s, I'm doing the same thing that I do when I work on my multiplication table. 9 times 8 is 72, so my big number is 8. 80 minus 72 is also an 8, just a coincidence. Denominator the same. Yes, it works. Even with the bigger numbers, it works. The technique works. How about 67 eighths? How many times did 8 fit into 67? 8 times 5 is 40. 8 times 6 is 48. 8 times 7 is 56. Getting there. 8 times 8 is 64. I realize that's the one I need because 8 times 9 is 72, which would be too big. 8 times 8 is 64. 8 is my big number. 67 minus 64 is 3. My remainder is 3. Denominator is the same. 8 and 3/8 is really the same number as 67/8. It is easier to see what you have with the mixed number, especially as the fractions are getting larger like this. But I have a few more to practice with. 67/8 was my last one. Okay, the next one's a little more gentle. How about 37/5? 37, fairly large number. Fifths, 5 is a nice roundish number. 5s are easy to work with. Students learn 5s early on in their math career. 5 times 7 is equal to 35. My big number is a 7. 37 minus that 35 is 2. That is my numerator. Denominator is the same. Let's write it down showing the steps again. 5 times 7 equals 35. 37 minus 35 equals 2. So the 7 went there, and the 2 is the remainder, and that went here. And of course, this 5 just sailed over to there because the denominator is always the same. It really is helpful that the denominator is always the same. Okay, how about 67/12? 67/12. 12 times 5 is 60. That's what I need. 12 will fit into 67 5 full times. 67 minus 60 is 7. And the denominator is the same. 5 and 7/12 is equal to 67/12. It works. We're doing a lot of them because this practice is what makes us feel comfortable with it and makes us good at it. We will need to do this sometimes when we're dealing with fractions. This will become just a step that we need to do simplification. of our answer, and this is a very handy way to be able to do it. What is my next fraction? I have room to write one here. 76/15. Again, we have 15, which is larger than the 12 times 12, but 15 isn't that hard to work with. 15 times 5 is 75. I happen to have memorized that answer to a multiplication fairly early when I was learning math. I don't know, just because the 15 was fun to work with. So 15 times 5 is 75. 76 minus 75 is 1. My remainder and my numerator is 1. 15 is my denominator. Are the students finding that this is getting too easy? It's possible the students are thinking this is too easy. Well, if it's too easy for you, it's probably because you've had quite a bit of practice and you're getting really good at it. And you're probably coming up with the answers before I even have a chance to explain how I'm getting the answers. And that's good news. It means the students are getting strong with this. I have one more. No, I have two more. I'll do both of the two more that I have. And you know what? I erased Mocha's mixed number. And now I don't know if I remember it. Uh-oh. We might not be able to use Mocha's. I'm not calling her down here again. I wrote it down, but I wrote it down on the chalkboard wall. I have to write things on paper. If anyone remembers Mocha's mixed number, you type it into the chat, and then I'll try to get to it. But of course, we're going to use it when we're going in the other direction to turn the mixed number into an improper fraction. But I still have these two examples. 53/15. Here I am with the 15s again, kind of like that. You know what? I'm going to change that into a 14. 53/14. Too messy. Let's erase it. Oh, I see something typed in. Okay, I'm going to make it 53/14. I think maybe the 15s were maybe a little too easy to work with. 14 is a little more awkward. Now, how many people have memorized all the numbers you get when you multiply 14 by various things? A lot of students won't be all that strong with the 14s because it's not in the 12 by times 12 multiplication table, but we can still do it because we know that all that table really is counting up by the numbers. If you want to step back to how you learn the multiplication table in the first place. So 53/14, that's a little messy, I'll get rid of it. 14, how do I figure out how many 14s fit into 53 if I haven't memorized all the answers? I count up by 14s. 14 plus 14 is 28. 28 plus 14 is 42. And if I add another 14, 42 plus 14 is 56, which is too big. So 14 plus 14 plus 14 is 42. That's the one I need. And that was 14 times 3. So therefore, my big number is a 3. The 14 is going to be the denominator. We know that. How do we find my remainder again? We have 53 minus the number we get if we multiply 3 by 14, which was the 42. 11. 53 minus 42 is 11. So therefore, 3 and 11/14 is my answer. It was a little bit more tricky, but we can still do it because we know how it works. And trying tricky ones later on after practicing a lot is a good idea because that's what puts us in a position where we're able to fight our way through a weirder looking question. So 3 and 11/14 is the mixed number that is equal to 53/14, and I feel quite confident in that. Yep, I feel quite confident about that. One more. One more that I have written on here. And it's enough because I'm looking at the clock and thinking, yeah, that works quite well for the amount of time. And here I am with the 15s again, but I'm not going to change it to a 14 this time because the numerator is so big. How many times does 15 fit into 127? Okay, let's figure that out. 15 times 2 is 30. And 30 times 4 is 120. But a 30 isn't the number we're working with, 15, which is half as big. Okay, so 4 30s fit into 120. That means 8 15s must fit into 120. I'm just thinking out loud here. I can also count up by 15s just to make sure. So I was saying 8. It fits 8 times. Am I right? 15 plus 15 is 30. Plus 15 is 45. Plus 15 is 60. Plus 15 is 75. Plus 15 is 90. Ooh, plus 15 is 105.
plus 15 is 120. Yes, 8 times 15 is 120, and another 15 would bring me up to 135, which would be too big. So my big number is an 8. 8 times 15, as turns out, is equal to 120. 127 minus 120 is equal to 7. Denominator's the same. We can figure it out no matter how big and weird the numerators and denominators get, because we know the tricks that will work, because we know how it works. And that's how math works, is when you understand how something works, then you're able to do the more challenging examples. Taking a quick look at the chat and the time. And now it's time to go the other way around. Now I could start right here, 8 and 7/15, and show how to turn it into this. But would I want to start? I'm Doug. Would I want to start with a big complicated one like this? No. I'd like to start with the simpler ones. So that's what we're going to do. And if anyone types into the chat Mocha's mixed number that I accidentally erased, I will use it. But if not, it means that everyone forgot it, not just me. And that could happen. That could easily happen. We have thrown a lot of numbers around in this lesson. Okay, other way around. From the mixed number to the improper fraction, I'm going to start with 2.5. Which is familiar because it was one of the answers way long ago. Aha, someone typed it in. That's great. So I'm going to put it over here. Try not to erase it this time, Doug. Okay, 8 and 1/6. I put it way over there on the edge, so hopefully I won't erase it. Went a little crazy with my eraser cloth there. Let's have some more chalk. What is the trick to convert a mixed number into an improper fraction? I like to write it like this. The big number, call it the big number, but it's really should refer to it as the whole number. The big number times the denominator. Okay, that takes a while to write down. Denominator. Those math words that are so long. Everyone loves that, eh? But then we have to add, so I need to do a plus, the numerator. This is going all the way across the chalkboard wall. These long words. But this is what we do. We multiply the whole number by the denominator, but then we add the numerator to the answer. And all of this is to get, not our final answer, this is to get our new numerator. Okay, I won't be writing this all over and over again. I will erase it soon, and then I will just be saying it. Big number, or whole number, times denominator plus numerator will give the new numerator. Okay, let's get our fraction bar in place so that we can write our answer. The big number is 2, and I'm multiplying it by the denominator, which is also a 2. So I'm doing 2 times 2. And that's going to give me 4. But then I also have to add the numerator, which is the 1. So it's a 2-step process. 2 times 2 equals 4, plus 1 equals 5. That's my new numerator. I can write it. This is the fun part. In going from improper fraction to mixed number, the denominator was the same. So you won't be surprised to learn that when we go from mixed number to improper fraction, the denominator is the same. And 5/2 was the fraction that Mocha chose right at the beginning of the lesson. So I used hers to go to the mixed number, and now I'm using that mixed number to go back to Mocha's 5/2. She must be thinking about eating 2.5 pizzas or 2.5 dog treats. Okay. So I may as well write my last part of the rule. It's a little crooked on my chalkboard wall, so I'll try and make it straighter. Denominator, here he is with another really long word. Denominator stays the same. How crooked is this looking? Not too bad. It stays the same. Okay, I'm not writing this over and over again. That's long. We do our whole number. We multiply it by the denominator. We get our answer. We add the numerator. That gives us our new numerator, and the denominator remains the same. It actually works way more quickly than it writes. So let's practice it a while. And of course, 2.5 was a fairly simple one to start with. So let's start with another one. Let's slightly, you know what? We'll gradually increase the size of the denominators as we're practicing. So my next fraction is going to be a mixed number that has a 3 as the denominator. And I'm erasing this. Yes, I am. After all that writing, here I am erasing it all already, but I will keep on saying it. Don't erase that, Doug. I will keep on saying it out loud as I work on this. I'll leave this one example up there. How about 7 1/3? Whole number, 7, times denominator 3. 7 times 3 is 21. Plus numerator 1, 21 plus 1 is equal to 22. Denominator remains the same. Big number times denominator plus numerator gives new numerator. Denominator stays the same. Not so bad. You can say it much faster than you can write it. Okay, so that's not so bad. 22/3 is equal to 7 1/3. Remember what we were doing before? If we want, we can do this on and on forever, back and forth. It's almost like what we call a toggle switch, where you go back and forth between two things that are equivalent. Okay, so using the technique I learned before, I'm hiding this mixed number from myself so I don't know the answer. 22/3. How many times does 3 fit into 22? 7. 3 times 7 is 21. So I have 7 as my big number. 22 minus 1 is 1. Sorry, 22 minus 21 is 1. That's my remainder and my numerator. Denominator stays the same. Are we surprised? No, we're not surprised. So we are able to go back and forth, and that is very useful. As we're working with fractions, moving on to more challenging levels of math, this technique is going to be used over and over again whenever we need it, and that is good. Okay, so that's the one with 3 as the denominator. Easy little numbers. Let's move right away to some that have 4 as the denominator. And notice how I'm not using Mocha's yet, because it has 6 as the denominator. So I'll wait until I get to the 6's before I take Mocha's and incorporate it into the lesson. The beautiful assistant has to have her fractions used. 4 1/4. And this will go faster and faster, of course, because we get good at it. Whole number 4 times denominator 4. 4 times 4 is 16. Plus numerator 1 is equal to 17. Denominator remains the same. It's like rolling downhill at the end when your denominator remains the same. 17/4 is equal to 4 1/4. How many times does 4 fit into 17? 4. If you put 4 into 17 4 times 4 is 16. 17 minus 16 gives a remainder of 1. Denominator the same. It is the same thing we're doing. We're doing it in the opposite direction. It sounds different. When you say, how many times does your denominator fit into your numerator, and then do a subtraction to get the remainder, denominator remains the same. Does it sound like the same thing as whole number times denominator plus numerator equals new numerator, denominator remains the same? It doesn't sound like the same thing, but it is actually the same thing. We're just doing the steps in reverse. How many teams of 4 can we make if we have a phys ed class with 17 students? We can make 4 teams of 4. There will be 1 student left over. That's the remainder. And of course, the denominator remains the same. It works. It's fun. That's one with a 4. Let's do another one with a 4. 5 3/4. 5 times 4 is equal to 20. Plus 3 is equal to 23. And I need a 4. I didn't say so many words as I described it this time, but I'm doing the same thing. 5 times 4 equals 20 plus 3 equals 23. And I can sort of feel myself going, the way I'm pointing at the numbers, I can feel myself going through this pattern that always works this way. 4 times 4 is equal to 16 plus 1 equals 17. Yep. 5 times 4 is equal to 20 plus 3 is equal to 23. This is getting easier. Okay, how about 1 1/4? Looks like the same question, but it's not. 1 times 4 equals 4 plus 1 equals 5. Same denominator. Not so bad. I could do some here, but it's going to get cluttered. I think I'll erase these and I'll do a few more. Have I used all the ones I prepared with 4 as the denominator? Yes, I have. Now it's time to do some with 5 as the denominator. Do we have to do it this way where we go gradually up in the size of denominators? No. I just kind of decided to do that because it sounded fun. And we could just mix it up. And of course, the supercharged students can handle that. So if I suddenly ask you, how about 8 and 7/12? You'd get it. Okay. 5 as a denominator. 3 and 2/5. 3 times 5 equals 15 plus 2 equals 17. Denominator's the same. It works. How about 3 and 4/5? Not very different. 3 times 5 equals 15 plus 4 equals 19. Denominator's the same. It starts to become rather routine. 6 and 1/5. 6 times 5 equals 30 plus 1 equals 31. Denominator the same. We are getting good at this. Okay, I have another one with a 5 as a denominator. I will use this space. How about 4 and 3/5? 4 times 5 equals 20 plus 3 equals 23. Denominator the same. 23/5. That was a little messy because my chalk got too short. I did it again. I finished another chalk. I'm really going through the chalk in today's lesson. I guess it's not to be surprised that you go through a lot of chalk when you have 42 examples in your lesson. Take a quick look at the chat. Okay, so I used all the ones I had with 5s. I'm going to do some erasing, and I'm going to take a sip of my fizzy water. I'm also taking a look at the time as well. Okay. Erase. Where are my 6s? I have a couple of 6s, but I also have Mocha 6. Let's do one of the 6s I already had first. 5 and 5/6. And if you know Doug, you know that 6 is just about my favorite word in math. Okay, maybe not. It's hard to say 6, but I can do it if I just slow down a little bit. 5 and 5/6. I refuse to be afraid to do this. Okay, equals 5 times 6 equals 30, plus 5 equals 35/6. Big number times bottom equals an answer, plus top equals new numerator. It's different ways of saying it. Okay, let's do Mochas. 8 and a 6. 8 and a 6 packages of dog treats, I guess, would apply to this. 8 times 6 equals 48, plus 1 equals 49. Same denominator. Now, if I went and showed her this fraction, would she make the connection? I don't know. This dog has some surprises in store for me. Taking a quick look at the videos. Okay. Well, Mocha's example was fun, just like all the others. Thanks, Mocha. Okay. How about, I have room. 9 and a 6. Oh, that's funny because this is so similar to this one. 8 and a 6, and now we have 9 and a 6. But the 9 and a 6 I had planned a couple of days ago, and Mocha plunked this one in. 9 times 6 is equal to 54 plus 1 equals 55. Denominator's the same. Okay. But I have a few more here, and the numbers are getting larger. And if the numbers get larger, maybe we need to slow down a little bit and be careful that we don't make mistakes as we do these little computations. So 9 and a 6 was the last one I did, and I guess now I can erase Mocha's contribution over here. 5 and 3/7. 5 times 7 equals 35, plus 3 equals 38. Denominator is the same. 38/7. How many times does 7 fit into 38? 5 times. 7 times 5 is equal to 35. So 5/7. 38 minus 35 gives a remainder of 3. Denominator stays the same. Double checking. We can always do it forwards, backwards. And that's a point I'd like to make, is that if you're ever in a position where you have to do this, and it's very important, and you don't have a way of double checking the answer, you don't have a calculator or a friend to make sure you got it correct, you don't need a calculator or a friend. You are your own friend. You can just take the answer you got and do the other technique and see if it's bringing you back to the original question. And that happens quite a lot in math, which is really convenient because it means that you're able to be in a position where you're doing something and you're able to check yourself to make sure that you're doing it right. Then you know you have the right answer and you can carry on with confidence. I like that. 5 3/7. Next one. 4 2/7. I'll bet you by the time I finished saying that, some of the students were already typing the correct answer into the chat. 4 2/7, because that's what it means to be a supercharged student. 4 times 7 equals 28 plus 2 equals 37. Same denominator. Okay, so the numbers are getting slightly larger, but is this technique getting more difficult? I don't know. It doesn't feel like it's becoming more difficult. Next one. Oh, I already jumped up to 8. 3 3/8. 3 times 8 is equal to 24, plus 3 is equal to 27. And my denominator is the same. 27/8 is my answer. 6 1/8 sounds very familiar because I had 8 1/6. But 6 1/8 is not the same fraction as 8 1/6, so there's nothing wrong with this. It may sound like it's the same, but it's not the same. 6 times 8 is equal to 48, plus 1 is equal to 49. Denominator remains the same. I think you can understand why Aurora was pointing out that the students should really know their multiplication tables before they start the fractions unit. Because boy, are we using those a lot. And knowing the multiplication tables is so handy when we're doing this sort of thing. 6 1/8. Next one. Oh, jumping up again. 9 1/9. More chalk, please. 9 1/9. 9 times 9 equals 81, plus 1 is equal to 82. Denominator the same. It is not getting harder. The numbers are getting bigger, but the technique is not getting harder. 3 8/9. Can I make it harder by not putting a 1, putting something bigger in there? 3 times 9 is equal to 27, plus 8 is equal to 35. Denominator's the same. No, it didn't get harder. 2 7/10. Okay, here we are with the 10. 2 7/10. I don't know. When it's me, whenever I see one with the 10, I think, oh, good. 2 times 10 is equal to 20, plus 7 is equal to 27. Denominator stays the same. 27/10 is equal to 2 7/10, and you can kind of see how right that is. Something about these numbers involving a 10 that makes it kind of easy to see. Yeah, 2 10s is 20 plus a 7 is 27. It's just jumping out at you that, yes, this is right, and I'm understanding it. So let's jump up a little higher. I'm almost at the end of my list of numbers. I'm almost out of time, but there's still a bit of time. So I think we need to do a couple of challenger questions at the end. We're going to have time for challenger questions. Those are the questions where Doug gets to show off a little bit. But I have a feeling the students can do them too. 2 7/10 was my last one. So the next one, yeah, it's a little bigger. 8 7/12. 8 times 12. That's getting down over to that bottom corner of the multiplication table. 8 times 12 is equal to 96. 96 plus 7 is equal to 103. We broke 100. Same denominator. On 103/12. It looks scary and hard, but it just isn't. How about 7 4/15? I'm jumping all the way up to that 15 denominator that I like so much. 7 times 15. Not in the 12 times 12 multiplication tables, but I still know that it's 105 because I've done a lot of math. And I find myself multiplying 7 by 15 every now and then. And I start having that feeling. 7 times 15 is 105. Is that my numerator, though? No, not finished. 7 times 15 is 105, plus 4 is 109. 15ths. Okay, I did that. I can handle this. I don't have any more examples, so I don't know why I would still be carrying this piece of paper. Let's see if I can create a challenger question or two that makes it harder. But I don't think it'll be harder. What I think is it will make us move a little bit more slowly. Slower, sure. Harder, I don't know. I don't think so. How about 23 and 11/17? Ooh, am I going to have to reach for my calculator? It's possible I might have to reach for my calculator. But wait, do I ever have to reach for a calculator? Not really, because first thing I have to do is multiply 23 times 17. I know how to do that. I know how to multiply with pencil and paper without reaching for a calculator. So 23 times 17. I need to do this, but it's just the beginning. 23 times 17. 3 times 7 is 21, so I have a 1. And I'm carrying the 2. Is that what I'm doing? And then 3 times 1 is 3 plus the 2. Yes. Yeah, that makes sense. Okay, then I put a 0 here. 2 times 7 is 14. I put a 4, and I'm going to carry the 1. 2 times 1, messy. 2 times 1 is equal to 2, plus the 1 is 3. I'm actually reviewing how to do this now. I haven't done this for a while. I add these together, and I'm getting 193. Is 23 times 17 equal to 391? Where's my calculator? Oh, no. He doesn't know where he put his calculator. There it is. 17 times 23. 391. I had it. I have to have more confidence. It's funny because when I do this, I feel a little awkward because I don't do it very often. Maybe it means that I should do it more often. I should practice it more. Because when I multiply 17 by 23, this isn't actually the way I usually do it. That's one of those Doug show-offy things. What I do is I say in my head, 10 times 23 equals 230. That's not hard. So that's 10 times 23. I also need 7 more times 23. 7 times 20 is equal to 140. But I also need, that was 7 times 20, 7 times 3. 7 times 3 equals 21. If I add these together, 1, 4, 5, 6, 7, 9, 2 plus 1. So that's what I usually do. But it's good to do this too, because it does sometimes get more complicated than 17 times 23. And even though I'm able to manage that, it was a little bit slow. And what if it was 1,741 times 2,582? Could I do it this way? It would take a while, that's for sure. Okay, so all of that to say 23 times 17 is obviously equal to 391, but I have to add the numerator, the remainder, yes, it is the numerator. 391 plus 11 is 402. Woof. It's a good thing the last step is the denominator remains the same. 402 over 17 is equal to 23 and 11/17. I just want to check it with the calculator again. But I'm feeling pretty good about this. 402/17. Yeah, I got it. So if we can do, and it doesn't have to get this crazy big. If you want to do one like, say, 11 and 7/12. Okay, it's still a bigger one. It's still more challenging, but it's not quite as big as this. But it's still good to do it. Take your time, fight your way through it. If you have that confidence that the technique you're learning works. 402/17. I'm going to write another one down. I'll erase some of this. I've checked the time. I'm getting right to the end of my time. But it's not really the end yet, so I'm not going to end the lesson right away. What I'm going to do is I'm going to try to do another challenger one, but in the other direction. I'm going to start with the improper fraction. I'm not going to use this one. How about 354 over 22? How many times does 22 fit into 354? I'll tell you one thing. I do not want to try to draw 354 stick figures and then try to make groups of 22. That would take too long. How many times does 22 fit into 354? Again, I can reach for my calculator, and if I need to, then okay, I do it. But I can say, well, 22 times 10, messy, 22 times 10 equals 220. I'm getting there, but it has to get a lot bigger. 22 times 5 isn't too hard to do. 5 times 20 is 105. It's 110, and that sort of makes sense. If 10 of these gives 220, then 5 of them gives a number half as big as 220. Okay, these add up to 330. I'm almost there, but I can add another 22. That's 352. Huh. So that was 10, 15, 16. Am I right? Now, 354 minus 352 is equal to 2, and the denominator remains the same. Let's check our answer. 354, 22. Oh, it's correct, except something funny happened, and it's because of the way I made up the question sort of at random. I ended up with the numerator-denominator part of my mixed number can be reduced. So I can divide those by a clever form of 1, which is 2 over 2. And it gives me, I still have the 16. 2 divided by 2 is 1. 22 divided by 2 is 11. 16 and 1/11 is an even more simplified version. I'm able to do it. So try challenging yourself. Don't necessarily do it at Doug level unless you feel ready. But try challenging yourself and realizing that even when you get really crazy, giant types of weird fraction, the techniques work. You have to have faith in the techniques because you will be relying on these basic fractions techniques for all sorts of math that you will be doing throughout the rest of your math career. And with that, I am going to end the class because I'm just about getting to the end of my time. So the timing is good. Thank you very much. Thank you, beautiful assistant, for suggesting such good fractions for us to use. Thank you for being so supercharged. I will see you next week, and I'm going to stop talking now and just wave goodbye and look at the chat.